Everyone, my name is Sanjay. Today I am presenting the IS1 of Dynamics of Machine. The IS1 is PowerPoint presentation on the effects of the aeroscopic couple on the aeroplane while taking turn. The introduction part is the gyroscopic couple plays a significant role in the stability and control of an aeroplane. Understanding this effect is crucial for pilots and aerospace engineers to ensure safe and efficient flight. The key parameters and relationships: C is equal to I into omega p. The I C is for the gyroscopic couple, then I is moment of inertia, that is mass distribution, and the omega is angular velocity of cohesion, Pm. Key parameters for the magnitude of the gyroscopic couple is determined by three main factors expressed. The formula C is equal to I into omega p. Moment of inertia I, this represents the mass distribution of the rotating parts, engine rotor and propeller. The heavier of larger diameter propeller increases the effector. Angular velocity of rotor, this is the rotational speed of the engine propeller. Higher upward results in strong gyroscopic couple. Then angular velocity of precision, that is the omega p. This is the speed at which the aeroplane is changing its direction, that is the rate of turning point, pitching up or the pitching down. Then the directional analysis and flight cases, the two determine how the aeroplane will get to be analyzed. The reactive aeroscopic couple based on the engine rotation, usually viewed from the rear pilot seat. While taking off, the rule of thumb, the x speed, the propeller shaft, the x precision, the direction of the turn or pitch, reactive couple, the resulting force that moves the aircraft in third perpendicular direction. For common scenario, assuming the propeller rotates clockwise when viewed from the rear side. Taking off, landing, left and right. When taking off, nose lifts up, aircraft veers to right. When landing, nose goes down, pitch down, aircraft is to the left. While taking left turn, wing is left, nose goes down, and right turn, wing is right, and nose goes up. Then the mathematical analysis and formula C equal to I into omega p. I is the moment of inertia, that is m into k square, where k is the radius of gyration and m is the mass of that body. Omega is 2 pi m upon 60, that is we have to convert that rpm into radian per second. Omega p is equal to v into r, that is radian per second. Omega p is equal to v divided by r, again this unit is radian per second. M is the mass, K is the radius of direction, and M is in RPM. V is the linear velocity, R is the turn radius. Then in this slide we analyze how gyroscopic couple affects the aeroplane during the two most critical phases of flight. The first one is case during takeoff, that is pitching over. As the aeroplane lifts its nose to plan, it creates a vertical precision. The effect of reactive gyroscopic couple acts horizontally. Thus, the aeroplane airs to at the pilot action. The pilot must act like left rudder to keep the plane straight on the runway. Case second, during the left action, the pilot initiates a horizontal turn to the left. Then its effect is the reactive gyroscopic couple acts vertically. The aircraft's nose dips down. That pilot action is the pilot must pull back on the elevator's pitch up to maintain altitude during the turn. Pitch up, climbing and override. If you pitch down and descending, your left is turning left, nose down, and then your right is turning right, nose up. Conclusion and key takeaways: the gyroscopic couple is not just a theoretical concept; it is a fundamental force that dedicates how the airplanes are designed and flow. Somewhere protect the wheels in motion. Any changes in the direction of the spinning rotor, engine rotor creates a reactive couple that acts perpendicularly to the motion. Perpendicular reactions by moving the engine rotation clockwise or counterclockwise. Pilots can anticipate if the plane will yaw or pitch during maneuvers. Design necessity: engineers use these calculations to ensure tail fins or control surfaces are larger enough to counteract these forces. And then final thoughts in pilot skill: mastering the right hand hold is essential for pilots to maintain stable flight during high power takeoff and sharp turns.